In the world of nuclear science and technology, radioactive substances have a big role in various applications, ranging from energy production as well as medical applications. This presentation explores the three separate radioactive substances: uranium 238, radium, as well as iodine 131, providing information on their properties, half lives, as well as how they helped in many applications.
Uranium-238. Uranium-238 is a naturally occurring radioactive isotope with a half-life of about 4.5 billion years. That is the forefront of nuclear materials. This longevity is critical given its principal use as a major fuel for nuclear power reactors. Uranium-238 generates power through regulated fission reactions, making it cornerstone in the global pursuit of clean and efficient energy source.
Nuclear power, fuel for electricity generation. Uranium-238 is a key fuel in nuclear power generation. It is used in controlled fission reactions to generate electricity. This clean and efficient alternative to traditional fossil fuels reduces greenhouse gas emissions, addressing environmental concerns associated with conventional energy resources. Next is nuclear weapons, fissile material. Uranium-238, though not as easily fissile as uranium-235, can be converted into fissile material, contributing to the development of nuclear weapons. This highlights the dual nature of nuclear technology and the need for strict international regulations and non-proliferation efforts to prevent radioactive material misuse. Lastly, radioisotope production, medical and industrial applications. Uranium-238 is important in creating radioisotopes, which have many applications in medical field and industry. These radioisotopes are used in medical imaging, cancer treatments, and radiography, demonstrating uranium-238's positive impact on various aspects of human life.
Effects. First, clean energy production through nuclear reactors. Uranium-238 is a key contributor to clean energy production in nuclear reactors, releasing vast amounts of energy through controlled fission reactions. This clear alternative to traditional fossil fuels contributes significantly to global efforts to reduce carbon emission and combat climate change. Second, radiation exposure risk, including health issues. The uranium-238, despite its potential for cleaning energy, can pose health risks due to radiation exposure. Workers in nuclear facilities and nearby communities may be exposed to ionizing radiation, increasing the risk of radiation-related illnesses, including cancer. Proper safety measures and regulations are crucial. Third, environmental contamination. Uranium-238 extraction, processing, and utilizing pose environmental risk due to the release of radioactive particles into the air, soil, and water. Careful management and risk environmental safeguards are necessary to minimize the long-term damage and ensure sustainable practices in the disposal of radioactive waste.
Uranium-238 is crucial for energy production, technology, and healthcare. But its use faces risks like radiation exposure, environmental contamination, and safety measures. Responsible and informed use is necessary to balance benefits with risks, ensuring sustainable and secure application of this radioactive element.
Radium is a brilliant gem in the history of radioactivity, attracting scientists and innovators alike with its unique qualities. This report digs into the world of radium, investigating its unique half-life of 1,600 years and revealing its historical usage, which range from medicinal treatments to bright paint applications. Simultaneously, we will investigate the impacts of this radioactive material, shedding light on both its possible benefits and inherent concerns, which must be carefully considered.
Now let's delve in the uses of radium. Number 1. In medical treatments. It was historically used in the early 20th century. Radium, with its radioactive glow, played a vital role in early 20th century medical treatments, marking a pioneering era in radiation application. But as technology advanced, its application evolved, introducing safer alternatives. 2. Luminous paint. It was used for glow in the dark applications. Radium's luminescent properties uh, led to its use in glow in the dark paints, used in watch dials as well as instrument panels. However, its hazardous nature led to a shift towards safer alternatives as well. Number 3, and the final use of radium, is the scientific research. It was valuable for nuclear physics and radioactivity studies. Radium's radioactive properties aid in scientific research in nuclear physics as well as radioactive studies, contributing to fundamental principles and understanding the advancements in nuclear science.
These are the effects of radium-226. 1. The improper disposal can contaminate soil and water, harming ecosystems and human health. The improper disposal of radium can pose environmental risks, including soil and water contaminations, ecosystem damage, and human health issues, necessitating strict disposal regulations. Number 2. Prolonged exposure can lead to radiation poisoning, causing systems increasing cancer risks. The radiation caused by exposure to radium can lead to radiation poisoning, nausea, and weakness, and increased cancer risk. Occupational safety measures are crucial to protect individuals near radiation-containing materials. Number 3. Radium-226 emits harmful alpha, beta, and gamma radiation. Radium-226, the common isotope of radium, emits alpha, beta, and gamma radiation for scientific research, but improper handling can be harmful, necessitating protective measures and safety protocols.
Radium is a fascinating element with a rich history. Has been used in medical treatments and luminous applications. However, its hazardous nature has led to a shift towards safer alternatives. Despite its value in scientific research, its effect require carefully consideration, including environmental risk and health hazard. This highlights the delicate balance between utilizing radiation for science and safeguarding against potential harm.
This presentation explores the use and importance of iodine-131. It's a radioisotopes with an 8-day half-life in medical treatments and diagnostics. It highlights its role in treating thyroid cancer, diagnosing liver function, and renal blood flow. However, the use of this radioactive substance requires careful consideration due to potential effects. The report emphasizes the therapeutic benefits of iodine 131 and the need for cautious use.
1. Treating thyroid cancer. The iodine 131 plays an important role in treating thyroid cancer due to its selective radioactivity. It helps in destroying cancerous tissues while minimizing the damage to healthy tissues. Number 2. Treating abnormal conditions such as hyperthyroidism. Iodine 131 is used in the treatment of illnesses such as hyperthyroidism. It regulates thyroid activity and normalizes hormonal levels. Number 3. Diagnosing abnormal liver function. The iodine 131 is crucial in nuclear medicine procedures for diagnosing abnormal liver function, providing awareness into organ function and aiding in the management of hepatic conditions.
These are the effects of iodine 131. First is the abdominal or stomach cramps. Iodine 131 administration can cause abdominal or stomach cramps, which can be experienced by individuals undergoing radioisotope-related treatments or diagnostic procedures. Second is the bone pain. Iodine 131 exposure can cause bone pain in some individuals, highlighting the radioisotope's impact on the skeletal system and requiring monitoring and management to alleviate discomfort. Third is the diarrhea. Exposure in iodine 131 would lead to gastrointestinal issues, including diarrhea, highlighting the need for healthcare providers to monitor and address any associated symptoms.
Effects of iodine-131. Number 4. Feeling of discomfort. A general feeling of discomfort is a common response to iodine-131 exposure. This subjective sensation may encompass a range of systems and underscores the importance of patient's communication and support during and after radioisotope administrations. Loss of appetite. Individuals undergoing iodine 131 procedures may experience appetite loss, affecting dietary habits, especially in tired conditions patients or those undergoing diagnostic imaging. Number 6. Exposure to the substance iodine 131 can cause a sore throat, affecting the upper respiratory tract. Monitoring those who got exposed and addressing the system is crucial for the overall well-being of those who exposed.
Iodine 131 is crucial in medical treatments and diagnostics, but its effect require careful patient care. It can cause abdominal cramps, bone pain, diarrhea, discomfort, loss of appetite, and sore throat. Understanding these effects is essential for promoting therapeutic advancement and patient safety in nuclear medicine, ensuring a balanced perspective.
In conclusion, the study of uranium-238, radium, and iodine-131 in nuclear science and advancement of technology reveals their complex applications and consequences. Uranium-238 is responsible for clean energy production, but also poses risks of radiation exposure and environmental contamination. Radium, a historical marvel, is used in medical treatments but requires safety alternatives. Iodine-131 used in thyroid-related conditions has therapeutic benefits but requires careful patient care. This exploration highlights the need for responsible use of these radioactive substances for human benefit and environmental sustainability.